Section 8.4, Properties of Logarithms. Well, the first property, there are three of them that we're going to go through in this lesson, but the first one is called the product property. Now, it says that if you have a logarithm of a product, and it can be any base you want, but the logarithm of a product can be split apart into two separate logarithms. Notice that the base has not changed. So of the individual parts. Now that is called expanding the logarithm. But the property works in the other direction too. So you can take the two individual parts and you can combine them together by only multiplying the arguments of the logarithms. And that's called writing it as a single logarithm. So you can use the property in either direction. So for instance, in this particular situation, we're going to evaluate log base 6 of 2 and log base 6 of 18 and add them together. I have no clue what log base 6 of 2 is. It's a weird decimal. You're talking about 6 to some power, which gives me the number 2. I have no clue what that is. Or 6 to the power gives me 18. I have no clue what that is. But according to this property, I can take this side right here and I can change it into this. So 2 times 18 makes 36. And so we're taking log base 6 of 36. Now we know that has to equal a number, so I'm going to write equals x. And I'm going to rewrite it into its other form. 6 to the x equals 36. Well, we know that 36 is really 6 squared, and as I said before, if the left side equals the right side, and the bases are the same, that you know that the exponents have to be equal also. So the sum of those two numbers is the whole number 2, but I do not have any clue what those decimals are, nor do I care. Now, the quotient property, which is the second one, allows me to take a division or a quotient and split it apart into two separate things being subtracted. The first property was addition. This one is subtraction. So every time I see subtraction and I want to change it back into something that's a single logarithm, I'm going to divide the arguments. So you can use it in one direction to expand the logarithm, or you can use it in the other direction to write it as a single logarithm. Sorry, I had a little bit off screen there for you. I apologize. So let's see if we can use this particular property. Evaluate log base 6 of 72, which I have no idea what that is, and log base 6 of 2. I want the difference between those two. Well, according to the quotient property, I can take this one, and I can put them together as a fraction, giving me log base 6 of 36, which we just saw a few minutes ago was the number 2. So I'm not going to redo that because you know that you can set it equal to a number and swoosh it around and find out that you end up with a power of 2, exactly like the last problem. But that's how we can use that property. The third property is called the power property. And in the power property, which incidentally was made famous by, here, I'll get the microphone a little bit closer. It was made famous in a movie, so hopefully you can turn down your volume. I don't know if you remember seeing this particular property, but it says that the exponent on the argument can be moved down and become a coefficient. So, you know, literally you can take this and move it down, and that's a legal move. Or you can take this and move it up and make it a... So this is the expanded form, and this is the single log form. Notice that the coefficient right here is a 1 in the single log form, whereas the expanded log form is a 1 up there. Okay, so if we said single logarithm, you would know that you would have to have a coefficient of 1, whereas if you had an expanded log, you'd have to have an exponent on your argument of 1. But the movie that this particular property was made famous in is the movie Madagascar. And you might remember the song where they were talking about the coefficient and moving it up and making it an exponent. You know, remember that song? I like to move it, move it. I like to move it, move it. You like to move it, move it. You like to move it. Right, that's the song, and that's referring to the coefficient, exponent, power property of logarithms. So let's see how we can use that. Here, I'll put my microphone back now. Hopefully you can stop laughing at me at this point. All right, so evaluate log base 2 of 2 to the third. Well, let's see here. According to that power property, I can take this and I can move it down. So we have 3 times log base 2 of 2. Now, log base 2 of 2. What is the exponent on 2 that gives me 2 to the first? The exponent on 2, which gives me 2 to the first. If you don't know what I'm talking about, then come over here on the side and write it down. It's got to be equal to some number, right? So you're going to rewrite it. 2 to the x power equals 2. Well, if this side is equal to that side, which clearly it is, and the bases are the same, then what do you know about the exponents? They're the same also. So this is 1. So in other words, this was 3 times 1, or 3. But we can use that power property in order to move that exponent down in front and simplify what we're dealing with. Okay, example 1 in your notes or in the textbook talks about identifying the properties that are used. So when I look at this, I'm saying what property was used to go from log base 2 of 8 minus log base 2 of 4 to log base 2 of 2. Yes, you were doing log base 2 of 8 over 4. That is the quotient property. We'll abbreviate prop for short. Okay, so I guess this particular question is all about, if I wanted to simplify it, about giving props. I know, that was bad. So let's move on to part B here. Want to see what properties were used. Well, I see addition right over here, so that must mean that we split this apart into two things right there. We did that part first, right? And that is the product property. And then, of course, we moved this down in front to get it in front there, and so that would be the power property. So two things were used there, the product property and the power property. So in example 2, it says write as a single log. Log base 3 of 20 minus log base 3 of 4. So this says log base 3 of 20 over 4, right? Using the quotient property, or log base 3 of 5. There you go. We wrote it as a single logarithm. We have not left it as two logarithms. We have, and what's our coefficient of the single logarithm? Always a 1. All right, so let's do the next example. There's going to be two steps in this one. First, we're going to use the property of moving it because we like to. That's right. So log base 2 of x cubed plus log base 2 of y. And then for our last and final move, using the product property, we are going to multiply those together and get log base 2 of x cubed y. Wow, that looks really familiar. Almost like one of the previous examples. Well, pretty close. They had a base of b, and this one's a base of 2. Same idea. Next, you're going to be expected to write things in expanded form. So I'm going to use, in this case, the quotient property to expand this into log base 5 of x minus log base 5 of y. In other words, we're taking this and splitting it apart. The numerator goes here on the left and the denominator on the right. And that is in expanded form. All of the arguments have an exponent of 1, so we're good right there. Okay, next, expand. All right, so the first step we want to do is we want to expand that product into the individual parts. So the product property allows me to split it up first into log 3 plus log r to the 4th. But then I need to use the power property and move it because we like to. And that would give me 4 log r. All of my exponents are now 1s, so we're good to go. All right, next example here. I want to split that up using the, you guessed it, the power property. The product property. So we have log base 2 of 7 plus log base 2 of b. And since all of the arguments have an exponent of 1, we are good. On this one right here, we want to move the power down first because we like to. And then we're going to write it in that form. Now, that 2 is going to remain out front, and then we are going to break apart this quotient, log of y over 3, in using the quotient property, log y minus log 3. All of the arguments have an exponent of 1, so we're good. Last one, I see a product, so I'm going to break that apart first. Log base 7 of a to the 3rd plus log base 7 of b to the 4th. But then, of course, we move these down because we like to move it. That was such a great movie. Whoa. Log base 7 of b. Remember, your bases don't change at all. We are skipping example 4, so you do not have to worry about example 4. It seems fairly complicated. The decibel system for sound is an intensity. Definitely follows the exponential scale, just like the Richter scale, but the particular problems that they're doing are a little bit more complicated than we need to do right now. Talk to you in class.